Hello, memory and cognition researchers. I'm going to go over chapter 6 of the memory text, and I believe it's also a chapter in the cognitive processes text, though I will get back to you on that one. So this is primarily for the memory class. Chapter 6 on visual imagery. So because this chapter is on visual imagery, doing this through YouTube is a little bit difficult because the majority of the chapter contents are something that I have some sort of video there that I want you to watch. So definitely go to the memory videos document, or if you have me in class, don't cheat and watch this online, actually come to class when we play the videos. But one way or the other, you'll have access to the different things via YouTube that I have structured to go into this PowerPoint so that it makes a little bit more sense and you get some actual imagery along with the chapter. So there's only 8 slides in my PowerPoint. Now, when you go into the one that's linked with the book, it's going to have a lot more in terms of slides and things that it covers, but I boiled it down to the main points. So in visual imagery, we're talking about just that. We're talking about the kinds of images that come to mind associated with different types of knowledge. It could be semantic, it could be episodic, it could be procedural, declarative, whatnot. Just the kind of imagery that comes up when you're recalling memories of any given thing. So there's one thing for sure, and it's when we try to activate visual imagery, we do create some sort of mental visual image of what it is that we're trying to recall. And depending on how detailed this image is, we can inspect the image and make certain types of decisions based on the image that we do recall. But it is extremely hard for memory researchers to study visual imagery. And I'll give you one guess as to why. So I know you all guessed it correct, right? You totally did. You nailed this. If I'm coming up with some sort of visual image in my head of something, it'd be very hard for you as an outsider to study my mental image because it's not something that you see. And because imagery is highly perceptual in nature and not everybody is going to remember the same types of details or prioritize the same kinds of information, my mental image and your mental image of the same exact things could be completely different if we were to draw out a picture or take a photograph of the same thing from the same moment. There's always going to be something that's a little bit off because it comes from a different perspective. So studying that is really difficult. If you're a memory researcher that's looking into visual imagery and you're trying to see what's going on in somebody else's head, until we get to the point of having eternal sunshine of the spotless mind type technology where we can go into somebody's head and walk through their memories, it's not going to be a very easy process. So everything seems to come in twos, right? There's 2 different ways that we can classify how we have representation of visual imagery in our memory. The first is called analog representation, which is that we store images in their picture form. And when we try to recall something, the theory is that we recall it like it would be in a photograph or the initial picture that we took it. So I'm looking right now directly at the webcam. There's all this stuff behind me. And I decide that I want to remember this moment. I want to know exactly what my computer looked like and my bookcase looked like and the quietness of no neighbors and no cats felt like. So I take a mental snapshot of this. If I'm going to recall it, this theory is that I will recall that snapshot of what I can see in this moment. Analog theory. Then there's something called propositional representation, which is that we store elements of imagery like code. So it's like a language in our brain of the different imagery that we have. associated with memory. And that when we recall it, this code gets run through our visuospatial sketchpad. Remember from Battley and working memory, it gets run through that, and then that sketchpad reforms these codes into a picture so that we can recall an image. So in this, you'd have just essentially a lot of code going on in your head. Think of like the Matrix. It's like scrolling around. And then when you put that code together, you piece things through your sketchpad and it makes the actual image that you want to bring up into your mind. So science research says that the analog means of representation is what happens, even though it is a more cognitively intense process, meaning that to look at this like an image and recall the exact image would be a lot harder than breaking this image down into a bunch of little parts, storing it like code, and then trying to recall it later. There's a few different studies that support this idea of analog representation over propositional representation. So if you go through either my or the PowerPoints associated with the textbook, you should see some imagery for these different studies. So the first is the Shepard and Mutlar's rotation study. And when you look at that, you'll see a 3D object, which looks like a bunch of cubes that are stuck together in some sort of very weird Tetris three-dimensional form. And even though when you look at this, you should see 6 different ways that this picture is rotated, it's the same picture. So what Shepard and Mutlar found is that the more you rotate this object away from the original picture, the harder it's going to be for participants in the study to identify that it's the same picture that they've been shown. So you can see in A, if you're looking at my slides, they've rotated it slightly to the right and slightly backwards, but it's still fairly simple for you to see that it's the same image from the left to the right. In B, they've rotated it almost completely in a 180, so it's a little bit more difficult for you to assess, yes, this is the same image from left to right. And then in C, they've completely flipped it in a 180 in a different direction. So B was like a 180 top to bottom, C is like a 180 left to right. And the study found that the more you rotate it away from its original form, the harder it is for somebody to say that the two shapes are the same. And part of that is because you're storing the initial image as it is when you see it. So you have to mentally rotate the object. And if you were storing something in code form, it wouldn't make sense that you would have to do this rotation of the image that you have in your head from being shown the image on the left versus the image on the right. So if you were to break down those cubes into some code form, it really wouldn't matter how they were shown to you. You'd have the same cubes and you recall them back up and poof, there you would have the picture. So you'd also, the quickness of saying yes or no, left to right would be much more rapid, even if they are rotated more, if it was propositional. So Shepard and Mutlar with their cube rotation studies say, yep, it's analog, we proved it. Koslin has 2 studies. So Koslin's first study is to ask you to picture a rabbit, but in 2 different contexts. So I'm going to ask you to picture a rabbit next to an elephant. Then completely separate that image and picture a rabbit next to a fly. And again, there's pictures in your PowerPoint and in my PowerPoint of this. So which one is easier for you to identify specific details about the rabbit? Now, if I ask you to picture the elephant next to the rabbit, and then I ask you for specific details about the rabbit, the chances are you're going to have less details, or it's going to take longer for you to recall the details because you're picturing a relatively small rabbit next to a pretty big elephant. So in your mind, you've made that rabbit a small image. And to find details from a small image is harder than having something that is larger and more easier to wrap your head around. So when I ask you to picture the rabbit next to the fly, you tend to think of a fly as being a really small thing. So if I'm going to ask you to draw it on a paper, let's say, you'd probably draw the rabbit significantly bigger than you would draw the fly. So if I asked you for details about the rabbit, it might be easier because in terms of the space that you have in your mental, visual, sketch pad, anything, say it's like, a typical square spot. The rabbit's going to take up the majority of that in your mental imagery. So you're going to be able to see the details in your mind a lot easier because it's bigger. So that's one of Koslin's studies, which again, if things were stored purely in code, it shouldn't matter what the rabbit's next to, because in code form, you should be able to determine particular traits of the rabbit, like how furry is it? Does it have 8 whiskers? Does it have 10 whiskers? Whatever it is. So that's Koslin number 1. Koslin number 2 is the imaginary map experiment. So to understand this, you need to pull up the map experiment. So if you don't have it in the PowerPoint, just Google Koslin map experiment and it'll show you the same general thing. And he gave people a map to memorize. And after he gave them some time with the map, he would ask them to picture the location of one thing in respect to another thing. So they'd look at the distance between the shoreline and the cabin, or the tree and the pond. And it was easier and quicker for participants to recall things that were closer together than things that were further away on the map. So by creating that distance, participants created a lag time for themselves because they memorized the picture in the exact order that things were, how far away things were, and the further away they were from each other, the longer it took a participant to scan from point A to point B in this thing to identify the distance between these different locations. So Koslin said, basically, if it was propositional, this makes no sense, because why is it taking us longer to identify these things or to come up with details for things based on their size or distance from one another? It's the same thing. What's making us have this extra time is because we are saving this image in its image form. So we have to parse these images based on how small or big they are or how distant they are and whatnot. Hope that made sense. So neuroimaging also supports the analog view. Now, when you're involved in certain types of tasks, like the tasks that Koslin and Shepard and Mutlar did, or just different kinds of imagery tasks, if I was to ask you to sit down and to recall an image of a duck or something random, and we were to do some sort of scan of you, we would see that your primary visual cortex and your occipital lobe light up when we do this scan. They get excited by you recalling this imagery. And if you have a damage to your visual cortex, it results in blindness. So we found a connection between analog representation, the type of tasks we ask you to do in analog representation, and the areas in your brain that are associated with visual imagery. So the same type of area in your brain lights up if I ask you to imagine something as if I were to show you a picture of something and you were actually looking at it. So damage to your occipital lobe also results in some types of visual perceptive disorders. So there's something called hemifield or unilateral neglect. And this is definitely one of the videos I want you to go and watch, because seeing it in a video is so much more impactful than me talking about it not having hemifield or unilateral neglect. But just a little summary here. I think I have a little paper. So normal people, if I was to ask you to draw a daisy, I was to give you a picture of a daisy, and then I was to ask you to write it down or to copy it, you'd have this picture and you draw the entire daisy. Now, somebody with hemifield neglect has a visual disparity in one side or the other of their visual world. So they can sit there and they can look at this daisy, whatever this flower is, and then I ask them to draw it, and this is how they would draw it. Give me a second. So if there was damage on the one side, you'd see them draw the daisy like that. They would not have that complete other side. They would have no awareness that it even exists. When I show them this one, they'll only see this side of it over here that I'm now drawing and marking on. Or they could have a similar thing if it was the other side. And maybe they don't even have the leaf now because it just wasn't in the side that they actually had visual acuity with. So the video shows a woman and she does multiple tasks where they ask her to draw the entire image. And no matter how many times they ask her to draw the flower in the task, she's always missing a side of it. And then they point out to her in the video that she is missing a side of it. And they ask her, you know, where is the left or right side? I don't remember which side she had the neglect on. And she's like, oh, well, I just don't see that. And it's really interesting to watch somebody actually have something like that and to be able to see it on video. So definitely go and watch that. Other aspects of visual memory. So one thing that people tend to show an interest in this class is photographic or eidetic memory. So people who have photographic memory, they have extremely heightened memory for details, but it doesn't necessarily mean that it's photographic because they're never going to have a perfect memory of something. I think it's impossible to have a perfect memory of something. Perception is always going to lead to some sort of discrepancy between what you see and what's actually there. It's just part of being human. So photographic or eidetic memorizers can remember things from like telling you what exactly is on my bookshelf left to right just by looking at it once. I have no idea. I see right now Hunger Games, Divergent, The Kill Order. Obviously, I like too many of these post-apocalyptic, like young teen, I think they call them novels. Whatever. We all do, all right? So they can tell you exactly what's on my bookcase just from coming in and scanning it once. They have that photographic memory. Sometimes it's for dates. Sometimes it's for names. Sometimes it's for faces. Sometimes it's for whatever it is. And a lot of times, well, sometimes people who have photographic memory, and there's another video of somebody who has this, have some sort of deficiency in some other area. Like maybe they have autism and their verbal representation, like words and language, are not something that they're particularly good at, but they're really good at recalling visual imagery. So there's a video of a young man with autism who he can ride over a city in a helicopter for an hour, and then he can go and draw the entire cityscape of that city to almost perfect detail just from seeing it once overhead, having no other context other than just looking at a sea of buildings. So it's another really cool video for you to watch. Cognitive maps. So cognitive maps are something that you have. You might not know it, but you have some of different locations, and there's something that you can create to help you represent some aspect of your external world. And it relies a lot on landmarks. So my biggest example of a cognitive map is that I can draw you in my head the exact layout of every target that I go to. Just let that sink in for a second. Target is a pretty stellar place, all right? Don't judge me. Somebody put a meme today, like, you don't go into Target looking for something, you go into Target and allow it to tell you what you need. So true. So true. So I can sit here and draw out to you, which would take a second, but everything I buy out, you walk in, you go through swimsuits and misses and women's and then plus size and maternity, and there's dressing rooms, and then there's men's and this and that, and then there's the shoe section and all the way into the corner and what holiday themes they set up and where exactly they put them by the holidays or their back to school stuff. It's kind of an obsession, but that's an example of a cognitive map. And if I was to ask you to draw your house, for example, so say you couldn't watch your way around your house, I made you put a blindfold on, you would probably be able to draw a mental map, a cognitive map for yourself with enough detail to get around your house from point A to point B without killing yourself or any of the cats that might be doing anything in the living room. Another aspect of visual memory is memory for faces. So this can go one way or the other. You have your typical average Joe who has decent memory for faces, not really great, not really horrible. Then you have something called super recognizers, which are people that can memorize faces, and they're so good at it that, and there's more videos on this, so go watch them. They're so good at it that you can show them an image of somebody when they were a child, and they could tell you who they were as an adult. Like you show them a picture of Barack Obama as a child, and they can automatically know that that's Barack Obama as an adult, or vice versa. You show a childhood picture of somebody, and they can just recognize within an instant who that person is. And then you have the opposite, which is somebody who has something called prosopagnosia. So somebody with prosopagnosia is not able to remember faces at all. So you might see people or hear somebody say, I'm really bad with faces. And it's true. There are some people that are genuinely bad with faces, and they have some degree of prosopagnosia to some extent. So basically, you cannot identify people based on the different characteristics of their face. And it's called, in layman's terms, face blindness, because essentially you could look at me if you had prosopagnosia, you could look away, and then you could look back at me. And if I didn't have some other characteristic that you had come to know was involved with me, you would forget that you even saw me. So some are so bad that, and in the video, like if I was to put my hair up in this video and not have it down like I've had in every other video, you would not be able to recognize that it's me. Or if my voice changed in some way, you might not be able to recognize that it's me. So it's a serious thing. Kind of sucks. And that was the extent of the visual memory chapter. There's definitely more to the visual memory chapter in the actual textbook related stuff. But if you go and you watch the videos, you can definitely glean a lot of stuff out of the videos, and the PowerPoint that's related to the chapter should be able to help you with anything that you haven't been able to do as of yet. And as always, if you have any questions with anything, just shoot me a message and I will answer it pretty quickly, because I'm pretty obsessive with looking at the canvas on my phone. So I hope that this did something for you, even though it's really short. And I will try to have chapter 7 up sometime this week.